Ladies and gentlemen, we're going to commence in a few minutes. Just for your friendly info, we do have some guests from a certain college, من القيادة والأركان. They'll be entering at the time and we will certainly welcome them, so I don't want anybody to be alarmed. And we will continue this plenary session as usual. Thank you. Okay. Good morning, ladies and gentlemen, esteemed guests. My name is Nawaf al-Nafisi and I will be your MC for today. Welcome to the fourth day of the IAEE International Conference. Today's particular plenary session is going to focus on energy, mobility, and technology. Before we get started, I'd like to introduce our moderator for today, who is Invita Aurora. Invita, in particular, is our program director for infrastructure and transportation at CAPSARC. Her research actually focuses on smart cities, freight mobility, and electrical vehicles. Before joining CAPSARC in 2018 February, she was the managing director and CEO of Innovative Transport Solutions in Delhi, where she was able to manage and conduct over 40 research and planning projects that contributed on city and country level, especially country authorities, as well as contributing with affiliation to funding agencies such as the World Bank, the DFIC, as well as the Asian Development Bank and the World Bank. So without further ado, I'd like to introduce Invita as the moderator, and she will introduce the panelists. Invita, the floor is yours.
Good morning, everybody. Good morning, Your Excellencies, ladies and gentlemen. Thank you very much, Nawaf, for that introduction. So mobility is a fundamental societal need and a key enabler of economic activity and a significant determinant of energy demand and, by extension, emissions. So in the coming decades, with the population growth, with the aspirations of economic growth, with the rising living standards, particularly in the non-OECD developing countries, there is expected that we'll have an increase of demand in transportation and all the associated energy needs with it. So this necessitates that we develop environmentally, socially, and economically sustainable transportation and energy solutions. And the technological advancements continue to play a very crucial role in creating such solutions. Ongoing development in the transport modes, including land, air, water, and improvements in energy efficiency, alternative vehicle drivetrains and fuels, automation, connectivity, new mobility solutions, and technology-enabled business models have the potential to transform the mobility systems of today radically. So we have a wonderful lineup of experts today on this panel to discuss some of these very complex but very fascinating topics, and it is my honor to have them on stage. If I may start with Andreas. Andreas Schäfer is a professor and chair in the Energy and Transport and a director of the Air Transportation Systems Laboratory, the University College of London Energy Institute. And previously, he's worked with the International Institute for Applied Systems Analysis, the Massachusetts Institute of Technology, Stanford University, University of Cambridge, and the list goes on. And he holds a MSc in Aerospace Engineering and a PhD in Energy Systems Analysis. Andreas? May I have you on stage? Then we have Dr. Geetam Tiwari, who is a Ministry of Urban Development chair and a professor of transport planning at the Department of Civil Engineering at IIT Delhi, which is incidentally my alma mater. She's obtained a master's in urban planning and policy and a PhD in transport planning and policy from the University of Illinois, Chicago, and also a degree of Doctor of Technology honoris causa from the Chalmers University of Technology in Sweden, where she's also a guest professor of sustainable urban transport. She's very well known internationally for her work in the area of traffic and transport planning, traffic safety, with a focus on pedestrian, bicycles, and bus systems. Geetam, may I have you on stage? And then we have all the way from Argentina, Gerardo Rabinovich, who's the director of the Mendoza Energy Company, EMESA, and he's an industrial engineer from the University of Buenos Aires, Argentina, and from the Energy Economics Institute with the University of Social Sciences in Grenoble, France. He's the vice president of the Argentine Institute of Energy, and I believe he has a long-standing association with the IAEA. Welcome, Gerardo. We also have with us from the World Bank, Radoslaw Czapski. We all know him as Rado, you know. So he's the senior infrastructure and transport specialist at the World Bank and the program manager for the GRSF multi-donor trust funds. And he has over 25 years of experience in large infrastructure investments, technical assistance to consulting projects. And he's been involved with a variety of projects in the transport sector, focusing on road safety, railways, urban infrastructure, transport services. And during his professional career, he's been managing and contributing to numerous global and regional country-specific studies, advisory, and technical assistance projects, particularly in Europe and Central Asia. Welcome, Gerardo, on the stage. And last but not the least, our keynote presenter for the day, Dr. Amer A. Amer. You've got 3 A's in your name, so I'm sure we are going to have a fantastic presentation. He's the Transport Chief Technologist of Aramco, the Saudi Aramco, with over 25 years of a very broad experience in transport and oil industries and academia. Dr. Amer brings a successful track record of mobilizing a significant number of global stakeholders around the world, and with a mix of transport solutions and energy vectors. And he spent the earlier part of his career with the automotive industry as an engine development specialist. And I think you'll see a flavor of that in his presentations also. He has co-authored many journal articles and patents. Amer, the floor is yours. Welcome.
Good morning, everyone. Assalamu alaikum. And thank you very much, Anvita, for the kind introduction. So Anvita touched a little bit on the fact that there is going to be significant increase in demand, energy demand that is globally. And of course, this is happening from non-OECD countries. And ultimately, we're looking at making sure that we're getting more energy, but with low emissions. So that's a big challenge for us. And my intent today is really to share with you some few slides here that hopefully will seed the discussion during the panel conversation that we have to afterwards. So let me get started. So again, given the fact that the demand of energy is increasing, and as I said, we're aiming to do that with less emissions, this is a look at basically the energy landscape as we speak, give or take a few months here. And the fact is, you know, the transport industry has been heavily dependent on oil. And not only that, but if you look at this very carefully, you will see that conventional resources constitute a significant share of the primary energy that goes into a number of sectors, including buildings, industry, and other sectors that use that energy. The one thing that I wanted to highlight as a takeaway is that given that heavy dependence on conventional resources, there is a need for us not only to focus on renewables, but also to look into opportunities that will result in immediate greenhouse gas emission reductions. Unfortunately, to a large extent, the resilience of these conventional technologies is really, you know, sometimes it's really overlooked. Not only that, but also the potential for greenhouse gas reduction associated with these types of conventional technologies needs to be taken into considerations when we move or when we transition from the current status to a future status which will have more renewables. So one thing that I also wanted to point out is the fact that, significant amount or a sizable amount of greenhouse gas emissions are not really abatable or not easily abatable. And what that really means is that there is more need for us to put more effort on technologies and technology development to ensure that we have those technologies that will result in significant greenhouse gas emission reductions. So this brings up the fact that R&D efforts need to be intensified, investment in R&D, but also these technologies would require some time. And ultimately, policy intervention would also be required to ensure that the future will result in something that is quite sustainable and that we transition in an orderly fashion from one status quo to the other. Now, this is another graph here that I wanted to also share, is that when we talk about greenhouse gas emissions, we're not only concerned with the newly generated greenhouse gas emissions, but also the existing greenhouse gas emissions. And that brings an important point, is that our focus should be on reducing both and eliminating, and reducing those greenhouse gas emissions quite significantly. And in fact, when we look at it, the amount of, or the approach to actually combine the reduction and removal of greenhouse gas emissions is the most effective way economically even. And the number that I have here is based on some internal assessment that we have done within the company, but also builds on studies by others, which basically estimates about $6 trillion savings globally by taking into account removal as well as reduction technologies to make sure that you have a big impact on greenhouse gas emissions. History matters. This is another slide here that talks about the dependence of transport on oil. And as you can see, 91% of transport final energy really comes from oil products. And this is only down by 3% since the early 70s. And what this highlights is that we need to put a lot of effort on reducing the environmental impact and making sure that transport is sustainable. We need to start looking at technologies that will result in immediate reductions in greenhouse gas emissions today. We cannot wait until all the technologies to mature and all the transport to be electrified for us to realize the emission reductions. This is not to say that we have to do one or the other. I think the point here is that we need to do both. Electrification of vehicles is something that will impact newly sold or new vehicles essentially. But keep in mind that you have over 1 billion of vehicles on the road today where they are still emitting greenhouse gas emissions. So improving the technology not only on the engine side, but also on reducing the carbon intensity of fuels that go into these vehicles will result in immediate reduction in greenhouse gas emissions. This slide here is really to show that there is quite a bit of interest or focus on transport. Back in 2030, transport was responsible for about 19% of the greenhouse gas emissions that will help us get to net zero. By 2050, this percentage increased to 27%, meaning that the transport now is receiving more attention, and there is a lot of push for reducing greenhouse gas emissions in the transport sector. And there is also a shift, in terms of the specific sectors, from passenger to heavy duty to aviation and shipping. As you can see, due to this growth in energy demand that is happening in non-OECD countries, you're expecting to have significant movement, and that is going to affect freights primarily, which is heavy duty and shipping essentially. But also, that sort of shifts the focus to the hard-to-abate sectors, essentially. Now, so what does that leave us with? There is quite a few potential solutions here. And if we look at the aviation, low carbon fuels, whether sustainable aviation fuels, whether they come in bio or synthetic fuels, these are basically the only realistic option. This is not to say that efficiency improvement will stop on engine or routes and all other aspects of improving the operational side of the aviation, but also the fact that to yield some significant reduction in greenhouse gas emissions, a big knob here is aviation fuels, sustainable aviation fuels, that is. When we talk about shipping, low carbon ammonia is a key potential decarbonization measure. Again, efficiency measures are still there. LNG ships, marine biofuels will continue to be the focus of greenhouse gas emission reductions. When it comes to road transport, we believe that there is a wide number of technologies that would be required to coexist to make sure that you have a sizable reduction in greenhouse gas emissions. And this does not only include internal combustion engine or electrified internal combustion engine in the form of hybrid vehicles, but potentially internal combustion engines that run on hydrogen, BEVs, fuel cell electric vehicles, but also low carbon fuels like biofuels as well as synthetic or e-fuels. And of course, you would appreciate the fact that not having a policy in place, especially for road transport, particularly because greenhouse gas emission or carbon intensity reductions that take place on the fuel is not something that is accounted for in the CO2 emissions. So policy intervention is key in this area. The other thing that to keep an eye on is the fact that the biofeedstock availability is limited. There is not abundance of that. Grid decarbonization is another front where some countries are heavily dependent on coal for their power generation. Charging infrastructure, accessibility to charging stations, but also the battery technology is another thing that is still evolving. Now, here's something that we have been working on within the company, and we believe that this is something it is one approach where we feel ultimately could yield significant reduction of greenhouse gas emissions and can address the challenge associated with climate, health, and energy concerns associated with the use of transport fuels globally. So, given the fact that electrification it will grow. I mean, this admittedly will grow, but conventional technology will continue to play an important role. And the fact that decarbonizing transport cannot be achieved without addressing emissions from conventional technology, one path would be to address the efficiency, look into novel combustion modes, but also look into novel engine technologies that will yield significant increases in efficiency that will reduce the CO2 emissions, but also look into the air quality aspects by reducing the criteria pollutant emissions. And ultimately, looking into sustainable low-carbon fuels. The nice thing about low-carbon fuels is the fact that they are true drop-in fuels that can be used in existing vehicles. But ultimately, the world will be looking for high-quality and credible offsets to make sure that you can continue to yield, that you can have affordable mobility while at the same time having significant reductions in greenhouse gas emissions. Here's just some touch points on the role of hybrids. So if we look at some study that we have done internally for China, if you look at the red zone, this is basically where gasoline hybrid electric vehicles are actually better than electric cars. And this is because the southern part, the renewable energy is more commonplace there. So the fact that you have significant dependence on coal, to generate electricity, it depends on which part of the country you deploy that technology. In some cases, a gasoline engine will actually, be better from a greenhouse gas emissions. If you look at the right-hand side, the question is always, or comes in the form of, if I have a limited amount of battery capacity, how do I use that most effectively? Do I put large batteries in big cars, or do I take that same battery and split it across number of cars? And this study here points to the fact that the return on, or the effectiveness of the battery actually diminishes when increasing the battery size. So it is better to have hybrid vehicles with increasing level of electrification, and that will give you a better outcome from a greenhouse gas emission, but also will give you a better utilization of an important resource that we have globally, which is the precious metals that are used to make these kinds of batteries. Hydrogen is also part of the story. And this graph on the left-hand side really points to one fact, which is green will grow over time. And we see significant growth in that domain, and we see significant plans and announcement by countries, companies, to make more and more hydrogen. However, the projected demand based on what's out there is not going to be sufficient. Blue hydrogen will continue to play a role. And that will come across different sectors. Some of those are hard to abate sectors when it comes to transport. One thing that is quite interesting is when you talk about hydrogen, there are opportunities to use hydrogen directly in an internal combustion engine. And that will give you significant reduction in the after-treatment cost for the engine. And this is because you're shifting the treatment of a wide range of pollutants to simply NOx, which is something that you know how to deal with. But not only that, using an engine like this will give the opportunity for manufacturers to leverage their existing manufacturing capacity. This is very critical for them, for the auto industry, because a manufacturing plant costs an automaker about $1 billion. $1 billion for the auto industry is nothing to speak of, but for the oil industry, it's a significant amount of sum. So essentially, there is significant interest to use an existing platform over and over. So if you have an opportunity to have an engine that can run on a wide range of fuels, or a fuel agnostic engine, like what Cummins, for example, has been talking about, there is a great opportunity to have significant savings for the automaker, while at the same time providing a solution that gives you significant reduction in greenhouse gas emissions, which is what H2 ICE engine is all about. Of course, another thing, I talked earlier about direct, credible and abundant CO2 removal from the atmosphere that can help in offsetting. And this here shows that, there is significant growing interest in looking into direct air captures. And there has been a number of announcements by a number of companies, including Saudi Aramco, that is working on direct air capture. We're aiming to bring the cost of this technology to less than $100 per ton of CO2. To put this in perspective, what this really means is that you're putting about $40 per barrel on top of the price, which if you think of the shale oil price, which is about $70, that brings the oil, the barrel of oil, the cost for a barrel of oil to about 110. So this is not extremely significant. But it's one of the things that we've been putting a lot of effort to mature this technology on the material side, and we're trying to demonstrate this technology with a number of players, and taking the price from anywhere between $500 to $700 per ton CO2 today to less than $100 per ton of CO2 sequestered under the ground, which is the objective that we have within the company, is a significant task. But we're quite determined and we're quite confident that we're going to get there. So let me share a few takeaways here before I close. That was too quick. Okay. So the point here that I'm trying to make is that the essential role of conventional energy in general, albeit with lower emissions, working alongside alternatives to allow for these alternatives to mature from a technology readiness standpoint, is very critical to make sure that we deliver on the net zero ambitions in the future without really looking at a holistic, at energy in a holistic way. We'll not be able to achieve net zero ambitions. And extending greenhouse gas emission mitigation scope from reduction to removal is quite important, whether it's in the CCUS, carbon capture, utilization, and sequestration, or in direct air capture. All of these technologies are required to make sure that you really not only looking into reducing the newly generated greenhouse gas emissions, but also what exists in the atmosphere today. And of course, the idea is really that technology agnostic measures will really give you the lasting reduction in greenhouse gas emissions. Picking winners early on in the game is not going to help. Ultimately, we have to make sure that we have a wide range of solutions in a number of technologies that will be deployed in a various number of sectors depending on their fit and suitability for that sector. But also timing is important, because if you don't start today, you're not dealing with the CO2 that already exists in the atmosphere, and you're sort of pushing that, pushing the bucket, the puck down the road. And then ideally you would like to have a portfolio of technology options, but also some technology enablers. Think about hydrogen and think about hydrogen storage on board vehicles and the technologies associated with that, safety, and so on. All of these have to come to the forefront to make sure that you have, you are quite, working very hard on reducing greenhouse gas emissions across the board. And of course, again, existing and newly created emissions need to be eliminated. And without having a technology agnostic approach, without looking at all options, without starting today and understanding that there is a role that conventional energies can play a significant role in enabling an orderly transition in the future, our ability to meet these net zero ambition is going to be severely hampered. With that, I conclude my seed slides here for the discussion today. Thank you very much.
Thank you so much, Amer. I think that was fascinating and really helped us to set the context to the conversation that we want to have. And I think one of the key things that you mentioned that I want to open up to the panel is that there's a huge amount of research that the industry and the research centers are doing in response to a lot of the climate agreements, the net zero targets. And I've always seen these two kind of pathways that are taken by policymakers So one pathway is always, it's a very prescriptive pathway with a regulated future where you say, okay, there's electric vehicles, there's hydrogen, there's synthetic fuels. So we have this set of things which are our pathways. And I admit, as a transport modeler, it's much easier if you tell me what I want to model, so I can prescribe, how this will lead us to our net zero targets. But the other one, which you've pointed out, and I think is more interesting, is a more technology agnostic, a more innovation-based pathways where you're showcasing that there is so much that is happening, but so much more will happen, right? And I think if we say look at 2050 or a 2060 or a 2070 net zero, we don't know what will come. What kind of disruptions can come, how much more research can be there. So if we all agree that there is one end game, that we have to reduce the emission and reach to these targets, what paths, what road we take to Rome could be many different roads. So out of these two pathways, and I know that there are, we have, World Bank experts and people from the city and academics around the table. It'd be interesting to get everybody's take on, how you see these technologies, or should we look at a more technology agnostic pathway, or should we look at a more prescriptive, or is it easier for an orderly transition? Is it better to have regulations and a formula in place? So Rado, if I can start with you.
Yeah, thank you. It's a very legitimate question, but let me start by thanking you for inviting me here. It's a great opportunity to contribute to the discussion. The dilemma that you have just described, Anvita, is clearly a dilemma faced by many governments, and both actually governments of high-income countries and middle-income countries or developing countries. And it is a multi-criteria dilemma. But when it comes to the World Bank policy in this respect and advice that we give to the regulators, to policymakers, to public authorities, we try to convince them that it's better to be more of an agnostic in approaching technologies and just set targets, set KPIs for different aspects of transition, because we are surrounded by transitions in practically every sector, every important aspect of change in our mobility patterns, in coming or starting from technologies through behavioral aspects, needs, and some sort of fashions in mobility. There are generational differences in approaching mobility. There is a lot of research going on by both private sector and academia. So things are changing fast. And locking ourselves in some solutions by regulating strictly may be dangerous, may be costly ultimately. But back to other voices.
Geetam, may I have your take on that? Yeah.
So, yes, thank you, Anvita. And I would also like to start by thanking you and CAPSAC for giving me this opportunity today. It's been wonderful last 3 days. I would like to start by pointing out a couple of things that we are talking about transport sector and especially mobility. And I think it's very important to understand technology obviously has a very, very important role to play in current challenges that we are facing. But transport is all about creating systems. Technology is one important component of that. So when we talk about meeting these increased demands, and especially you also showed that how increasing demands are going to be in low and middle income countries, the demand is different. The demand will increase differently in different sectors. And therefore, locking ourselves with one or two technologies obviously is not a good idea. And I think you also pointed to that. But when we are talking about creating transport systems, investing only in technology or relying only on technology innovation may not be the answer either. Because many innovations happen because of setting targets by governments, regulators are required. So a judicial mix of both is required. And if I can just give a quick example that, all technologies that we are talking about is addressing about, let's say in the best case scenario, 60% of our trips. 30 to 40% of trips in low and middle income countries are low carbon without technology. These are walking and bicycle trips. So for 60%, we have to invest in all these technologies. And the system, the regulation will ensure, the policy intervention will ensure whether we are talking about taking help of technologies to address, let's say 40% of the trips or 60% of the trips. That will make a huge difference. So in the end, I would say that we do need a judicial mix of the two. lot of innovation will happen because of appropriate regulations, but we have to be technology agnostic. And just like in safety, we have a set vision 0 for future. So here we have net 0 vision for carbon emissions. That's a very laudable vision, and we have to work hard to get to it. So we have to do a lot of backcasting. So let me stop here.
Yeah, thank you, Geetam. Gerardo.
Thank you, Anvita, and thank you for the invitation. The organizer, thank you for giving me the opportunity to transmit our works in our region, in South America. We, in the last years, working on a project called Enabling Conditions for Investment in the Transition to a Low-Carbon Society in LATAM, with focus in Argentina, Brazil, and Peru. The goal was provide evidence for necessary policy reform and contribute to map out the conditions that may result in the decarbonization of all the sectors of the economy. The financial flows had to be consistent with the requirement of low-carbon pathways. Prioritization criteria for project selection was greatest contribution to reduce emissions, capacity to transform social and consumer behaviors, and technical, economic, and financial feasibility. Very important. We find a set of options. Electrify the largest possible amount of energy, final energy consumption in the sectors with higher carbon intensity. Decarbonize the power generation, decarbonize the grid, reduce the energy intensity, and replace with innovative solutions everything the other consumptions that cannot be electrified, hydrogen, biofuels, etc. Then we propose a number of actions and the development of electric vehicles, of the EV solution in big cities like in our region meet all the requirements. We, as usual now, developed a model for net zero emission 2015 for Argentina to see how it had to be achieved that goal. What we need to make. Today in the country we have 14 million of cars, but less than 200 are EV. We start from 0. The estimations of growth are 2.5% by year. And we estimate for 2030 a share of 12%. That means 2.4 million cars, and 75 in 2015, near 18.5. We have 25% solutions for other technologies. Capital requirements, well, from now until 2030, $7.4 billion a year. The next decade, $54 billion a year. And next, near $100 billion a year to transform the sector. About main cost for this solution is in the range that Amer showed, $330 million for ton of CO2 avoided. That's impossible, maybe. But we not find another solutions now available in the short term that the anthem of our generation. Imagine there is not ICE in the transport road in the future. It's the challenge.
Thank you, Gerardo. Andreas.
Thanks, Anvita, and of course I also start with thanking you for having me here. In answering your question, I believe I would suggest it depends. I mean, normally you would think you don't want to constrain the brilliant minds of engineers, whether in industry, at Aramco or other places, whether at research institutions or universities, but in order to find the most creative and elegant solution. On the other hand, there may be markets in which regulation makes sense just to exploit economies of scale and in which there are not many alternatives. So, but in general, I would tend to the former. Now in aviation, that's what I've been working on intensively over the last 20 years or so. A key question is, what is the silver bullet? Or if there's something that comes closest to the silver bullet, and Amer mentioned it, it's the fuels part, because if fuel efficiency improvements are going to happen anyway, because the market forces exist in order to implement fuel-saving technology, whether it's on the aircraft, whether it's air traffic management systems, or whether these are operational measures. But these are not sufficient to bend down the curve because of the demand growth. Then the question is, what fuels have you got available? Well, there are synthetic liquid hydrocarbons, and you can get very close to net zero, whether they're biomass-based or hydrogen-based with atmospheric CO2, and you presented all the opportunities there. Or the alternative is direct use of liquid hydrogen. And then would you invest only in one of them? Well, of course not, because we don't know yet which path to pursue. And if you look at different actors, whether it's different countries, different industries, some of them have a very strong opinions, or surprisingly strong opinions, and you ask them for the underlying reasons, and some of those are surprising, I would suggest. My personal perception is, if you really want to go towards direct use of liquid hydrogen, well, you need to have very good reasons for it, because it's a major infrastructure transformation, very capital intensive. And the only reason I can think about is the non-CO2 part, which is in the size, of climate forcing, roughly comparable to CO2 in aviation. Yeah. And if it turns out that through the direct use of hydrogen, you have more flexibility of influencing NOx, which is very likely, and also cirrus, or let's say contrails and their transformation to cirrus clouds, then that's a very good argument for making this extra step.
Now, I think that brings a fascinating perspective. And Amer, I'm going to put you on the spot because, you must have presented a lot of these innovations and technologies and these options to different policymakers and governments and industry. What has been their response to something like this?
Well, is this working?
Yeah.
Well, most of our communication and engagements have been with the industry, with our colleagues, but also from the global energy industry, but also given the fact that we are, as a company, not in the business of making cars and engines, our direct connection has been with automakers. And what we hear from automakers is they fully understand the limitations and the policy push behind battery electric vehicles. And many of them, if not most, are keeping their options open. And the fact is, they still have a number of engine programs in-house. And they also understand that the demand is happening on the other side of the world, where the electricity is not fully decarbonized and so on and so forth. So what we see is that these automakers have a wide portfolio, and they continue to have significant effort behind developing innovative combustion technologies and innovative hybridization and dedicated hybrid type engines, while at the same time they look into electrification and so on. One of our recent discussions that we had with the CEO of a major company in Europe was the fact that automakers currently are not making any profit on any EV that they're selling in the market. And they understand that this is going to take some time. And if they continue with 100% electrification, first of all, they cannot electrify the entire fleet because there are some smaller cars for some specific markets that are, where you cannot electrify. The cost will be prohibitive for people to buy. And the other thing is that other vehicles are not very well suited because of battery size, for electrification. So they're keeping their options open. They continue to work on internal combustion engines. We have a number of joint development agreements with a number of automakers that aim at introducing these technologies in the coming years. Some technologies are keeping their options open in the sense of really having a common engine platform where they change the top part of the engine depending on the fuel. So the bottom part, which is the most expensive, is something that can run any kind of fuel, whether it's liquid or gas, and the top part will change as you basically change the gas. So some innovation is still happening. Some companies are pushing a lot of behind hydrogen, and they're looking into hydrogen as a bridging strategy, putting that into an internal combustion engine, given the fact that the purity level for that hydrogen is significantly lower than what you would require for a fuel cell. So we see acceptance of the policy push, but at the same time we see quite a bit of effort that continues to happen. A few days ago, GM announced a new engine, even though this is one of the companies that said we are all about electric. They just announced a program, $1 billion investment in a large engine, which is usually a gas guzzler. So that's quite interesting. But I think, in my humble view, I see that as you have more and more models that are electrified, people will understand the limitations of this technology and the fit. There is no doubt that in city centers like, where you have highly populated, there is no doubt that electric vehicle will result in immediate improvement in air quality. There is absolutely no doubt, and there is a great fit there. But in other places, the cost, the technology, the infrastructure, all of that is still evolving. And as you introduce more and more technologies, I think people will realize the limitations, and there's going to be a resurgence of the need for conventional energies that will bridge the gap until these other technologies mature.
Yeah, thank you very much, Amer. And I want to kind of shift a little bit and pick up something, Geetam, on what you pointed out earlier. If we zoom out of the technologies and we stop focusing on only carbon, and as you said, transportation is a systems thing, and there is much more, and there is much more to sustainability than just reducing carbon. If we can talk a little bit more about, the economic and the social and the other aspects of bringing in sustainability if we move out of the carbon. Sorry. Yeah.
Yeah, I think it's really important to understand that we know that most countries have actually accepted the 17 Sustainable Development Goals which has been set out by UN. And out of these 17, 7 are directly related to transport and 5 are indirectly related to transport. So almost more than 50% have something or the other to do with transport. And it's important because, after all, it is about overall sustainable development, and technology is going to play an important role there. So I see that many times there are synergies with low carbon transport technologies, but there are also conflicts with some of the sustainable development goals that we are seeing. For example, goal 3.6 is about reducing number of traffic deaths by 50% globally by 2030. So now I'll give you an example from India, or let's say it is applicable to actually India and all of most of African continent also, where mobility is growing not because of cars, but mostly because of two-wheelers, motorized two-wheelers. Motorized two-wheelers have a very good option of switching to electric. It's a small battery, and it's happening in countries like India and many other Asian countries very fast. Because it's so easy. You can even go for battery swapping even if the charging infrastructure is not there. So this is all great. And obviously 70% of our fleet is two-wheelers, so we are going to see a lot of pollution benefits also. What happens to goal 3.6? Two-wheeler has the highest risk. The only protection you have is helmet. That is only 30% effective. So with increasing clean fleet of two-wheelers, we expect to see more number of people getting killed on our roads. So there is a conflict here. Yep. Because you want to reduce carbon, but you also want to improve safety. But there are, on the other hand, synergies. You look at goal 11.2, it talks about accessible public transport systems. There you have win-win for both. And many of our countries, including India, we have a very strong program for having electrifying buses. But now I want to pick up on something you just now said, which is so important, that electric buses, there are a lot of unknowns right now. We don't know in long term how it's going to perform. So instead of straight away going for 100%, emphasizing on 100% conversion to electric, we have to go slowly, understand all the barriers and problems that we are going to face, and we have to keep on solving that through new innovation and R&D. So I would say that eventually we have to place low carbon in the context of, and there are whole 3.6, 3.9, 11.2, it all talks about many other aspects which are equally important for all our cities and all countries. So it's important to see where we have strong synergies and where we have conflicts. So I would say emphasize on synergies.
Yeah. Well, thank you very much for that, Geetam. Andreas, have you seen, in the aviation sector specifically, with all the push for the technological advancements, have you seen any kind of unintended consequences of some of these technological advancements?
Well, there are positive and negative unintended consequences, let's say like that. So a positive one, and Amer mentioned it, is local air quality, which is, until recently, has been in addition to noise, aircraft noise, was the binding constraint for airport capacity expansions, NOx emissions and particulates.
Yeah.
And to whatever fuel, synthetic fuel you move to, you get improvements, particularly, of course, with direct use of hydrogen. And perhaps unintended consequence is, but it's one that can be expected, I suppose, is, so we said fuel efficiency improvements are going to happen anyway, and then you move towards one of these synthetic fuels, and they're, of course, more expensive than if you get crude oil out of the well, which requires very little processing. So there will be an increase in fuel costs, and airlines have to pass that somehow on in some form to the passengers, so the airfare will increase. This results in a demand drop, of course, which from a CO2 mitigation perspective is a welcome opportunity because you don't have to push these more expensive technologies into the system to the extent you would have to otherwise in the absence of these demand drops. But the increase in airfare, of course, is something that would make this concentrated activity of flying, which mainly the higher income groups enjoy, even more concentrated. So based on our simulations, and we just published a paper jointly with colleagues at MIT and Imperial College London in a journal called Nature Climate Change, in which we looked at the cost and emissions pathways of aviation towards net zero climate impacts, not CO2 impacts. So our analysis suggests that the increase in airfare would be around 10 to 15% if you make this transition, using actually similar numbers as you presented in terms of carbon capture costs of below 100 tons of CO2 in the long term. So it's not a game changer. Aviation continues to grow, not at the same rate as before, but not much smaller. but the increase in airfare will not provide increasing access to those who already were disadvantaged. Another potential unintended consequence I can think about is the attempt to achieve some of these targets that have been articulated by Joe Biden, for example, the 3 billion gallons of synthetic aviation fuel by 2030, or the World Economic Forum's Clean Sky Initiative of supplying 10% of the aviation fuel globally in 2030 through so-called sustainable aviation fuels. And they should actually be called more sustainable aviation fuels, but anyway, that's a separate conversation. The challenge here I see, or the danger I see, is there's only virtually one technology, readiness level 9 technology available, so that's commercially available, and these are hydrogenated vegetable oils. This is what Nestle produces, Sky Energy and the like. This can be done today and is being done, and you can scale it up to around 10%, and here we are, so that target may actually have been set in understanding that that's the size of this market, of this fuel. Now the challenge is, if you want to move towards net zero, then you can think about having two straight lines. One goes from today to 2030 with an increase of around 10%, but then the other straight line is like this, because in 2050 you need to cover the entire market with these fuels. But this technology is not scalable. So you need to invest in the scalable ones at the same time. And it is being done, but probably not at the rate as it should be. So power to liquids, direct use of liquid hydrogen and so forth. These technologies must be market ready and deployable at scale in 2030. And that's a big challenge. And I may know too little, I don't know. But it seems that there's too little research going on in these complementary but highly significant alternatives, not alternatives, complements to hydrogenated vegetable oils.
Yeah, thank you for that. Before I go further, ladies and gentlemen, there should be a QR code up here for questions that the audience can ask. I can see already a couple of questions had come in, but please continue with your questions. We'll take them after we close with the panel, and I have a couple of more questions. But Rado, just coming back to, the technological advancement, there are consequences of the technological advancement. What is your experience with the different countries? How have they created an enabling environment for the adoption of these technologies? And then how are they monitoring these unintended consequences?
These are very important aspects, particularly in the transition period where you have emerging technologies, emerging new business models, how to make them, how to try them in practice and how to make them attractive, how to demonstrate that they are useful and they contribute to achieve our objectives. And there are obviously roles to be played by both key sectors of the socio-economic life, which is public sector, government, municipal governments, and private sector. Both of these segments of our life can create some sort of mechanisms that will give chance to new technologies to mature and to be tested. And actually, there are different mechanisms. There are technological labs that both private, big players, private sector, commercial players establish and nourish and invite startups, invite new ideas to develop, to mature. And there are some kind of sandboxes on the public sector side sometimes where you, on one hand, give umbrella coverage to new business models, to applying new technologies in practical daily life, and you give coverage because in some places regulatory regimes clearly do not follow sufficiently quickly the developments, and actually, if taken literally, may prevent development of new modes of mobility. The example is electric scooters. In some places where there is no regulation whatsoever, any business that could that would like to put scooters in the streets in the city could have dozens of inspectors coming, hey, asking, have you certified your vehicles? Well, there's no procedure for this. How have you assured security of users? Well, there's no insurance mechanism that we can use. So this kind of sandbox process gives an umbrella to those kinds of new business models to be tried, legally tried in the environment, and then by monitoring the results, both intended or foreseen and unintended consequences, communicating this very openly to market players and reporting back what were the results of these kinds of trials. I cannot underline strongly enough that communication is crucial here. Yeah. Transparent communication, and that's where the research community comes into play as well, because there is a role for researchers to analyze objectively and present to general public and decision makers all of these consequences, to what degree the solutions contribute to our KPIs, and what can be improved.
Well, that's fascinating, and that gets me back to Gerardo, because you are working with the country, with the cities, and I think for developing countries have limited resources, right? They have to start prioritizing what should we focus on. Then they have to develop these systems, as Rado had said, around regulations around it, the monitoring protocol. Then they have to do the communications to ensure that people know what to do. So again, it is a systemic intervention that needs to be done. So how are you prioritizing some of these initiatives that will lead to a more sustainable transport future?
Well, communicate is very important, or to the policymakers, but we need big reforms in not only the transport sector, in the economy at whole. We find very important technical barriers. Implement new solutions take time. And we have deadlines that are near from us. We need to planify the new infrastructure, the new grids, the new electrical and charge infrastructure, and it needs hard investment too. We have economic barriers all over for the electric vehicles, because the price of an electric vehicle for the people is 50% more than an ICE. And that needs fiscal incentive and maybe subsidies to push the penetration of the technology in the market. In our countries too, we have high financial barriers, because we have weak markets, weak financial markets, right. And the consumer leader, the loan access at low rate of loans, it's very critical, very critical. And finally, but not least, we find very important regulatory and institution barriers. New regulatory framework to overcome the social opposition, the union oppositions, because we put in new business model in the electric sector, new business model in the car industry, in infrastructure of charge, and it's very, it's very complex operation. And we need to communicate to overcome these important barriers.
Yeah, I think that's really important, looking at the barriers and then figuring out how to go across them. There's a very interesting question that has come from the audience, Amer, that I want to take up before I take up one of my other questions that I have. And that's a conversation between electrical cars versus hydrogen cars. You know, it's saying that a lot of economies which are transitioning now to a different, you know, adopting different technologies, instead of going for electrical cars, can go to hydrogen cars, you know, just leapfrog over the electrical cars. So it's a question from the audience. I don't know how you want to take that.
I guess I think they have, both have roles to play.
Right.
And if I were to paint a future, you know, I would want to use battery electric vehicle or the battery electric capacity to power as many cars as possible to make sure that I have the biggest impact on greenhouse gas emissions with increased level of electrification through hybridization. But I also, depending on some of the needs for some of the applications, fuel cell make a lot of sense because in assuming that, you know, that the cost goes down, because right now the cost is quite prohibitive. So as the cost comes down, they will make sense for very large trucks, for example.
Right.
And that's where, so depending on which sector and the cost of the technology, the total cost of ownership also comes into play. So it's not really, it's either or. I think both technologies have a role to play depending on which sector, which country, which infrastructure, and what, you know, what model you have for the total cost of ownership. And I believe that they will both play a role in the future. So I don't think there is, you know, competition per se. Right now, you know, fuel cells are quite heavy. You know, when Toyota made the Mirai, it was about $120,000. The first Mirais that they have made. This is very significant. It is affordable by a small section or smaller group of people. And the technology cost has come down significantly since that time. And I expect that, you know, with more advancement in technology, this will come even further down. So it's a total cost of ownership towards the end of the day is how you can judge.
Thank you very much for that, Amer, and I hope the questions answer. Rado, I wanted to come back to you on, you know, there's a point you made about business models. And in fact, in one of our earlier discussions when we were, you know, I have to tell the audience, we had a panel discussion before we had a panel discussion when we all met together and we were talking about, you know, some of these issues. So you said that technological models need to be converted to business models, and you raised that point in your earlier conversation also. So what's your experience with the World Bank on that? How are you supporting the cities to do that? Is that something that is, you know, a part of your capacity building? How is that being addressed?
It is obviously a complex task, and I mentioned already some mechanisms, but I wanted also to mention the leading by example schemes that are useful in many respects. Not so much talking about business models per se, but kind of indirect support to new products, new technological solutions, and indirectly supporting new business models as well. Because cities, for example, cities introduce more and more of eco modes of mobility. I mentioned the example of electric scooters, but there are bike for rent schemes in most of big cities where you make convenient last mile solution accessible to general public, to wider population, and handy. And this comes with business models because these are private sector providers who are providing these kinds of services. So basically these rent-a-bicycle schemes are run by the private sector, but upon request, after sort of transparent tendering process invited by the public sector management. And similarly, a lot of public services for example, a lot of public services use vehicles. We should, and we convince public sector partners that they should order vehicles that are fulfilling higher emission standards, emission requirements in a sense of reducing emissions, switching their fleet more to greener fleet, and demonstrating effects and reporting back the effects, using it also for sort of promoting these new modes. So that's what I call leading by example.
Yeah, thank you very much for that. And so I think there's a last round of questions that I want to ask, because I think this is really critical and we need to close with that. You know, it's the million-dollar question. Yes, we know we need more energy-efficient transport. Yes, we know we have to reduce carbon, and we know how to do this. So we've got all the technological options. We've got a whole basket of solutions in place. Where is the money coming from? I think that's the big question. Where should it come from? Who should be investing in it? And we've seen a lot with the work with the subsidies on EVs and things like that. Can consumers make better choices without the sticks? And can an industry make better choices without the stick and carrots? Can we just make better choices towards a sustainable future? What does it take to invest in something like that? And Amer, maybe I want to start with you and come back to Rano.
Well, I think it's the chicken and the egg. Which one needs to come first? I think investors will not put any money without any policy, without any view or vision that this will, materialize in money, because that's what they're interested in. So I think there has to be sort of hand in hand, and initially there has to be some government intervention to introduce some incentivizing vehicles to make sure that these technologies are going to be kicked off. Because it's not going to happen. The investors alone cannot do it. The automakers or the technology developers are not going to be able to work alone and put a technology in the market that nobody is willing to buy because it's quite expensive.
Yeah.
If you look at the, I go back, with Toyota when they introduced their, hybrid, the Prius hybrid vehicle way back in the 90s. They lost money, about $8,000 on each and every vehicle that they have sold. But their intent was really to incentivize the market. Eventually, they opened up all the patent portfolio for everybody to basically start making hybrid vehicles. Some other opportunities lie in some direct government intervention to create and catalyze a market and create some funds that will bridge the gap between the cost, between the demand and the supply, essentially, what people are willing to pay versus what the technology really costs. And then policymakers, they have, in my view, ultimately we shouldn't be regulating technology. They should be regulating emissions and allow for technology to compete on a level playing field and provide the incentives to do that, or the mechanisms and vehicles to do that. Investors will come to the table because there is something in it for them. Then the technology developers will see the value and then take the cost down and do what they're very good at. Without all of these coming together, it's not something that could materialize in something that will make a big impact, I think.
Yeah, Andreas, the aviation sector is the most super regulated and the hard to abate sector. So what's your perspective on this then?
Amer is continuing to preempt my messages here.
I cheated.
Well, as you said, there needs to be a business case. Without business case, there won't be any investments. And so that's the role of the government. That's exactly what you alluded to. And again, these synthetic fuels are more expensive than the ones you can get out of the ground. So you're always in a disadvantage. And so there needs to be a mechanism in order to make them, put them on a level playing field, whether it's a carbon tax, whether subsidies, which of course is not a long-term solution, or the like. Now, getting investors aligned once there is a business case shouldn't be any problem. I believe the global amount of equity and debt financing is $400 trillion or so, and we are talking in the aviation sector of required investments of around 2.5 trillion, so it's 0.5%. That shouldn't be a big deal. And interestingly, and that's maybe also an unintended consequence, most of the investments would actually go in power generation, not in the aviation sector, because you need half of the current capacity, or let's say production, that's a better metric, added in terms of renewable electricity by 2050. So it's a massive, massive investment. But again, if there's a business case, investors come. And recently there was a Guardian article that suggested that the profits of the oil industry over the last 50 years were $3 billion per day. And then you compare this to the 2 to 2.5 trillion, that's peanuts in comparison. So again, a business case through policy, and the investors will come. Now that's also easier said than done, because aviation is a global sector. You need to push it through the ICAO and all these committees. It's not impossible.
Yes, Gerardo.
Sorry, go ahead.
Yeah, oh, okay, go ahead.
I was just going to mention, even when you talk about, for example, synthetic fuels, of course, make sense in where renewable energy is abundant and hydrogen production is very cost-effective or low. Areas like Saudi Arabia, like Australia, like Chile are very ideal places to make that. But eventually, who takes credit for the CO2 savings? And whether making blue products, and in my view, we should be colorblind when it comes to those energy carriers, whether it's ammonia or hydrogen. But ultimately, how do you take credit and how do you transfer credit to the consumer towards the end of the day is part of the policy that needs to be cater for that. Otherwise, regardless of how much you incentivize that, if the credit stays with somebody and you don't get it, then you haven't achieved your scope 3 emissions or 1 and 2 emissions and so on.
Yeah.
So that's just to complement maybe what Andreas was.
That's an very important point.
Yeah.
I think. Yes, Gerardo.
Well, I think that I saw a mix of technologies for transform the transportation sector. But I think that the big car companies choose the technology of electric vehicles. Tesla, Volkswagen, Ford, General Motors, and the reduce the emission is mandatory for the next years. We are, in the case of our countries, the world have commitments by country in the NDCs, in the Paris Agreement. And I think that the big contribution to reduce emissions is transform the transportation sector in the big cities. It's massive, they need massive investments, but two kinds of investment. The private investment, the driver and the car companies, and the public investment for the infrastructure that it may be public investment with the private sector too. But the technology is in place and is possible. For the public transport, for instance, in some countries we have the possibility to put the biofuels. In my country we have a very important production of biofuels to replace oil products. Hydrogen is not a technology mature, but it can be quickly implemented in new solutions, but in the longer term. Yeah. We have steps to hide. And the liquid fuels in the long-distance heavy trucks, duty heavy trucks, could be substituted by natural gas with LNG and natural gas compressed for the short distance. And I think we have, as I said, Amer, we have a mix of technologies in different stages that could be implemented. the oil and the natural gas will have an important role in the transition, and we can discuss any technology and know how implement the solutions for the most important goal, that is reduce emissions.
Right. Thank you, Gerardo. Geetam, what are the levers that would make this change then?
I mean, I think I want to raise another important aspect, because we all have talked about importance of government regulations. That is how the markets get created for new technologies. That's absolutely important. But again, if I look at transport sector, creating markets for technology may be a necessary condition, but not sufficient conditions to meet our net zero targets. And this is especially true, I guess, everywhere, but definitely true for low and middle income countries, where, as I said in the beginning, majority trips continue to be walking and bicycling and public transport. So new technology bus, biofuel or electric, whichever efficient technology, low carbon, if it gets stuck in congestion, I'm not going to use it. So we have to go beyond technology. We have to have regulations and policies that a new clean bus can move without getting stuck in congestion. It is also important to understand that one has to walk to a bus stop. You have to access a bus stop. If my walking environment is not safe, I'm not going to use bus. And also, so when I see the current debate and discussions and where country budgets are going, and Indian Parliament has just discussed the new budget, there is a lot of emphasis on green technology, green budget they call it. But my disappointment is, where are we talking about creating infrastructure for public transport, and majority public transport in cities will continue to be bus-based. Metro is important. It's excellent for long trips. If majority trips are going to be shorter trips, we have to rely on buses. So unless we do this policy intervention to create, I would say, a conducive or commuter-friendly environment to use a public transport, technology alone will not solve the problem. So I would say we really, really have to emphasize on seriously considering how we retain, and in future, 2030 or 2050, at least 30 to 40% trips which are outside vehicles. Yep. Unless we do that, I think it's going to be very difficult to meet any net zero scenario. And forget, just one last point, it's not again just about air pollution or local or global. Health benefits. There are umpteen studies which show that your impact on cardiovascular diseases, cerebrovascular diseases, Alzheimer's, we cannot solve by clean vehicles. I think through evolutionary processes, we are designed for walking. So unless we have, and I really, there are so many young people sitting here, I would like to ask them this question: what is your vision in 2030? You wake up in the morning, would you like to see 16-lane corridors in cities full of clean cars? Or would you rather see blue sky, people walking, and children happily walking to school? It's your vision that will dictate what happens in future. Thank you.
Thank you very much for that, Geetam. I think it is a very important perspective to bring transport back to the systems and the fact that we are not an island in the large scape of human living. Rado, any last thoughts on that? Yeah.
I only wanted to re-emphasize that this famous rule of 10,000 steps a day, we have to follow it. We have to do it daily. And actually, we haven't touched this topic. I'm very supportive of this approach. And whatever the World Bank is doing in supporting public partners, we try to do it comprehensively, precisely, try to assure that, first of all, people have most of daily services, including their workplaces, within 10, 15, 20, 30 minutes of walking or combined walking, cycling, and friendly modes of transport, rather than commuting from one end of the city to the other. For these longer distances, we are promoting public transport options and investing World Bank money and incentivizing governments and municipal partners to invest in mass transport modes, where technology plays great role and where many of those newer, innovative technological solutions should also be piloted and analyzed. So there is a wide spectrum, but let's think systematically and let's analyze, monitor, and provide feedback on what comes out, what lessons we are learning, to the general public, to specialized professionals.
Thank you for that. And I think this panel has been exceptional in highlighting really the complexity of the challenges when it comes to the transportation sector. The transportation systems are not an island, so we are affected by technology, but also governance, people's choices, temperatures, you know, the way the land use policies are, how far do I have to travel, where do my children go to school, and, you know, so everything affects the mobility choices that are made. And hence, looking at it more from a systemic or ecosystemic perspective and seeing the place of how can we get all of that together to go to a better, more sustainable and green future. You know, so thank you very much to all the panelists for really highlighting that. And before I close, really, I want to mention, ladies and gentlemen, that right after our session, we have a set of concurrent sessions that do a deep dive on some of these issues that have been raised. And I know there are fantastic researchers who are presenting in some of those concurrent sessions. So, you know, you should take these conversations forward in those sessions. But coming back to the panelists, I'm extremely grateful for all of you for coming and this absolutely fascinating discussion that we've had today. Thank you very much, everybody.
Thank you, ladies and gentlemen. بس نبي نرحب بضيوفنا اللي جايين ما شاء الله من كلية القيادة والأركان. شكرا لحضوركم على المؤتمر and for attending this very interesting conference. We do have a panel discussion at 11 that will focus on data, models, and simulators to advance energy and climate policy decisions. The first session will be about policy decisions, enabling data availability and gaps. Our moderator will be Sadim Al-Hussein. Thank you.